There's a fifth way to combine functions, and we call that the composite function. If you read the statement here, it says given f and g are two functions. So again, we're going to put those two together, but instead of adding, subtracting, multiplying, or dividing them, we're going to take the composition of f and g. And this is how it's written. And what we say is f of g at x. So here, we're going to put in an x value, take the function g of x, and then what that results in, we're going to put that in for x in f. So let's try one. We're going to do this a couple of ways, all right? We're going to do this graphically, algebraically. The first way is kind of the easiest. It just gives you a few points here. Here's x and f of x, x and g of x. So let's do this first. If we were to say, what is g of negative 1? Well, you look over at the g function, and when x is negative 1, we get that it equals 2. So now we're going to take that value and replace it in the original function. Okay, so we're going to say now f, and instead of g of x, we're going to put this 2 in here. And we're going to say, let's take f of 2. All right? And that, if we look right here, f of 2 equals 0. All right, let's try another one. So first, we're going to take f of 1. What is f of 1? It's negative 1. So they're going to go f of, and what is f of 1? It's negative 1. Okay? And then if we go, what is f of negative 1? It's 3. Okay? Be careful when you do these. I don't want you to do this one. I'm going to do this one incorrectly. All right? I'm going to say, well, what is f of 2? f of 2 is 0. So I'm going to write equals 0 here. And then I'm going to say now g of 0 is 1. Do you see what's wrong here? This actually doesn't equal this, and 0 certainly doesn't equal 1. So we're not going to do it like this. Okay? Instead, if you need to figure out what f of 2 is, do it down here. f of 2 is 0. So now I can put it back into the original equation. 0 goes here where f of 2 is. And now I can figure out the g of 0 is 1. Okay? So that's doing it with a table. Let's do the same kind of question, but this time we're going to have to go find the values from the graph. So your first step here is, what is f of 3? Well, here's the f function. At 3, we get the value as 2. So I'm going to write g of 2. Now I go to where is, if x is 2, what's the value of g? It equals 0. Okay, let's try the next one. What is f of 9? So I'm going to take f of, and f of 9 is going in there. So at 9, looks like f of x is 3. So then I'm going to go and say, all right, now if we go to 3, what is f of x? It's 2. Okay, so hopefully that makes sense. We'll try it now. So the first time the table gave you some values, then you had to go and find them. Now we're going to have to do this algebraically. We're actually going to have to figure this out. You'll probably want to do some writing here. So let's figure out, what is g of 2? Well, you go over to the g function, and it puts 2 in to the x right there, and you end up with 1/5. Okay? So then I'm going to say, what is f of 1/5? Now notice I haven't put an equal sign here or an equal sign here. That would be incorrect. What I've got is separate statements here. Okay? I've got this one, where I'm figuring out what is g of 2, and now I'm going to do f of 1/5. Okay? So that's 1/5, take away 1. Let's find common denominators. 1/5 take away 5/5. So this is negative 4/5 in the absolute value, which equals 4/5. So now I can answer this is 4/5. Okay, let's try this one. what is f of 2? You get the absolute value of 1, which is 1. And so then I'm going to say, well, what is g of 1? G of 1 is 1 over 1 squared plus 1, which is 1 over 2. So I have 1/2. Okay? So those are just finding some values. Now we're going to look at something a little bit different. Here you have, there's no value for x here. We're just supposed to do this algebraic composition. Okay? So what I'll do is I'll say the f function is the red one, and everywhere that is, I'm going to put red ink. So if I want to do f of g of x, okay, and I'll leave the g one to be green. All right, what I'm going to do is put the g of x function in here. So I'm going to have f of x minus 3 over 2. And now I'm going to put that into the f function. So I get 2, and instead of x, I'm going to put this in for x. I get x minus 3 over 2 plus 3. Okay, so just so you're clear, this is 2x plus 3. Here's my x value. Okay, and then simplifying this is x minus 3 plus 3, and you get x. Okay, let's try g of f of x. See what happens there. So I'm going to write the g function, and my f of x function is 2x plus 3. Okay, so now I'm going to put this in for x in the g function. So I get, well, here's the g function, but instead of x, I'm going to put in 2x plus 3. And now simplifying that, I get 2x over 2, which is x. Now that's strange. They both equal x. That's actually a special case. In general, f of g of x and g of f of x are going to be different. In other words, usually if you do this, it's different. If they by chance are the same and they both equal x, then these two functions are inverses of each other. Do you remember what inverses are way back from earlier in the year? Inverses are when we take, if xy is on one function, then the point yx is on the inverse function. We just switch x and y values. You might want to go and revisit that from back in the very first unit. Okay, so these two functions are inverses of each other. If you remember in the first unit, we actually did this algebraically. How do you find the inverse of this function? Well, you switch x and y. So you would write x equals 2y plus 3, and now solve for y. So you'd have x minus 3 is 2y divided by 2. You get x minus 3 divided by 2. This is the inverse of f. And if you notice, it is g of x. So that would be another way of doing this. Now, I'm going to give you a little bit of a heads up here. On your test, there's a question where it says, use composition of functions. Use composition of functions to show these functions are inverses of each other. Okay, so if you see that, this is what it means. Okay? So, given f of x and g of x, determine an explicit equation for each composite function. Okay. So let's take the composite function f, And instead of g of x, I'm going to take g of x and put it in here. All right, and now I'm going to take this value to be x and put it into the f function. Okay, so then I would say, all right, here's x, and then it's 3 times x. So in the function originally, this is x and x, but instead of x, I'm going to put in 2x minus 1. Okay, and you could simplify this, we could expand it all out. This is 4x squared minus 4x plus 1 plus 6x minus 3. So you get 4x squared plus 2x minus 2. Okay, that's f of g of x. Now what is this? Do you recognize this? You should recognize this as a parabola. Okay, now if you know it's a parabola, you know that you could figure out what it looks like. We could find the vertex, we could find the x-intercepts. Okay, this question says, state the domain. Well, what's the domain of a parabola? The domain of a parabola is always negative infinity to infinity. What if we needed to find the range? Well, then you would have to find the vertex. And you know that this one opens up, and you could find the vertex. And then you could find the range. Okay? Let's try another one. So, g, and what is f of x? F of x is x squared plus 3x. Okay, and so now we're going to put it in g of x. G of x is 2x minus 1. But instead of x, I'm going to put x squared plus 3x. Okay, so I'm going to get 2 times x squared plus 3x minus 1. Okay, so just wrote that in there for you to see. You don't need that. And simplifying this, you get 2x squared plus 6x minus 1. That's g of f of x. Again, this is a parabola, so what's the domain? Negative infinity to infinity. Okay, why don't you guys try this one on your own? So you're going to have f of x squared plus 3x. And then we're going to put this in for x in f. And if you remember that this is like so, and we're going to put that in for this x, and we're going to put that in for this x. So it looks like x squared plus 3x squared plus 3 times x squared plus 3x. Okay, so are we clear what's going on there? We're replacing this is my x, so it goes in where the two x's were in that equation. Okay, and simplifying, well, this is going to get a little bit uglier. Okay, and then you have plus 6x cubed plus 9x squared plus 3x squared plus 9x. Now what kind of shape is this? Well, you can see this is a quartic. And what is the domain of a quartic? Negative infinity to infinity. Okay. And a little bit of a shorter lesson. We'll stop there. That's page 298. You could do numbers 4 to 6, 7 to 11, 13, and 14. Okay.